All right. If you're looking at this problem, this is a relatively simple equation to solve. I'm going to subtract 2x from both sides of the equation. I'm going to add 4 to both sides of the equation. Then we're going to divide both sides by 3, and I'm going to get x equals a value. I lost track of the value somewhere in there, but it's a relatively straightforward solution. So why am I pausing and talking before doing a relatively straightforward problem? Well, I want us to think about what are we actually doing here. And I don't mean like existential crisis, oh no, what am I doing? No. What I'm talking about is what's the meaning behind the math? What are the implications of this equation? And I'm really starting to think graphically. Because what I'm actually doing is I have one function on one side of the equation and one function on the other side of the equation. And so I just as easily could have written this f of x equals 5x minus 4, and then g of x equals 2x plus 5. And then this equation could just as easily be written as f of x equals g of x, solve for x. Whoa, what did we just do? Well, when I think of f of x and g of x, I think of the output, right? I think of the output of the equation. So what I'm really saying is the output of the equation on the left equals the output of the equation on the right. Well, those are y values, right? If I'm graphing this thing, those are y values. So I'm saying the y value of the purple function equals the y value of the black function. And I'm trying to find an x value where that's true. Well, if I sketch this, and first of all, the first 2 lines I sketch are not going to be these lines. I'm just going to draw two random lines here. What I'm really looking for, I'm saying I know these are both linear, so it's reasonable to sketch them both as lines. And I'm just throwing 2 lines up there. But what I'm looking for is the point where the y values of f of x equal the y value of g of x. Well, that's only going to happen at the point where those 2 lines intersect. And so what I'm actually solving for, or the x that I'm actually finding here, is the x value for the intersection of those 2 points. XS for x solution. But so that's the particular x value that's the intersection of those 2 lines, those 2 functions. And so when I've got an equation like this, the math may be relatively simple, like it's going to be relatively straightforward for this one. But what I'm actually doing is finding the x coordinate of the intersection of the left-hand side and the right-hand side. All right, let's do the math and let's convince ourselves of this. If I sketch this, what do I have? I have y equals mx plus b, right? And so my slope of my purple line is a positive 5, and my y-intercept of my purple line is a negative 4. And so I'm going to go down here to 1, 2, 3, 4, negative 4, and I'm going to put a dot right here because that's where my purple line crosses that axis. See, I told you the first one was just thrown on the axis somewhere. All right, now the slope is rise over run, and 5 might as well be 5 over 1, right? And so what that means is as this goes over 1, I go up 5. Well, I went down 4 below the axis, so I'm going to go 1 above the axis to go up 5, right? And so that means I've got to point at the 1, 1 that's on this line. I could always test myself by putting in 1, 1 and seeing if it's true, which it is, because 5 minus 4 is 1, 1 equals 1. But you can play with that on your own time. It can be shown that some of the most terrifying words in the mathematician's vocabulary. It can be shown that. All right, so I got a rugged sketch of a line here. All right, now let's sketch the black line. Now, its y-intercept was up at 5. So if I got 1, 2, 3, 4, and 5, and so that means all the way up there at 5, I'm going to put a black dot on the y-axis. Now, as it went over 1, it went up 2, right? Because it's got a slope of 2. And so as it goes over 1, it's going to go up to 7. So 5, 6, 7. So that's going to be the next point for it. And probably should use the color of the line, the black color of the line, and sketch myself a line that goes up from there. Okay, so that's the sketch of the situation. Now let's do the math of the situation. So I had 5x minus 4 equals 2x plus 5. All right, well, I want to move the 2x to the left-hand side, so I'm going to subtract 2x from both sides of the equation. I want to move the 4 to the right-hand side, so I'm going to add 4 to both sides of the equation. Whole reason I'm adding 4 is because that equals 0. Whole reason I'm subtracting 2x here is because that equals 0. But if I do that to one side of the equation, I must do it to the other side of the equation. All right, so now I've got 2x minus 5x, that's going to give me 3x. Now I've got 5 plus 4 is going to give me 9. And for some reason, I'm thinking I might have said things wrong earlier, done the math wrong in my head earlier. But anyway, here we go. I've got a 3x here, right? And so I'm going to divide that by 3. I'm going to divide that by 3. It's the only way to get that to be 1 times x, because 3 over 3 is 1. But if I do that to the left side, I must do it to the right side. Now, 9 is a funny number, right? Because 9 is 3 squared. So what I really have is 3 times 3 divided by 3. Well, 3 over 3 is 1. 1 times 3 is 3. So those 3's cancel. And I'm left with x equals 3. Wait a minute. 1, 1, 2, 3. Sure looks like that x-coordinate where those two crossed. So how could I find the ordered pair where those two lines intersected? Because I've got the x-coordinate, I don't have the y-coordinate. Maybe, just maybe, I could find that y value, right? Because what we're saying is that this coordinate system, poorly drawn as it is, keeps going on up for forever and ever, right? And so what we're saying is that somewhere on this coordinate system, there's a y value that corresponds to that intersection. And I need to know it. So we'll call that, y sub solution, y sub s. And I want to find out what that y sub s value is, what that number actually is. Well, if I know the x-coordinate, then I can go back to either of my functions and put 3 in for x, and I should get the same value out, because if the whole point of this exercise was that the y value of f equals the y value of g at this x value, if I put that x value in, I ought to get the same y value out of each function, right? So let's do that just kind of for practice. So if I do f of 3, that's going to give me 5 times 3 minus 4. Well, that's going to be 15 minus 4. That's going to be 11. So f of 3 equal to 11. All right, now let's do g of 3. Well, that's going to be 2 times 3. Oops, I ran out of space. I'm going to do the teacher with a tablet cheating and slide over and create some more space. Plus 5. Okay, well, that's going to be 6 plus 5. And so my g of 3 is going to equal 11, which, fortunately for my ego, is the same. Because I just told you that they should be the same, because what we just found is the intersection of those two lines. So this point, 3, 11, should be on both lines. So the intersection doesn't like me to draw in the lower left corner. Intersection of f of x and g of x is 3, 11. I hope that helps with the concept of what we're doing when we solve an equation.